Nicolaus Copernicus, born on February 19, 1473, in the town of Torun in the Kingdom of Poland, is often remembered as the father of modern astronomy for his revolutionary heliocentric theory. His life and work marked the beginning of a profound shift in scientific thought, challenging the long-standing geocentric, Earth-centered model of the universe, which had been accepted for nearly 1,500 years. Copernicus was the youngest of 4 children. After his father's death, he was taken under the guardianship of his maternal uncle, Lucas Watson-Rode, who became the Bishop of Warmia. Watson-Rode played an instrumental role in Copernicus's education and career, arranging for him to study at the University of Krakow. Here, Copernicus was introduced to various disciplines, including mathematics and astronomy, which sparked his early interest in the heavens. He would later study at the universities of Bologna, Padua, and Ferrara, where he pursued a wide-ranging curriculum that included medicine, law, and the humanities. These studies not only expanded his intellectual horizons, but also gave him the tools he would need to challenge the scientific conventions of his time. During his years in Italy, Copernicus began contemplating the structure of the universe. The dominant cosmological model at the time was the Ptolemaic system, an Earth-centered model developed by the ancient Greek astronomer Claudius Ptolemy. According to Ptolemy's model, the Earth was the fixed center of the universe, with all celestial bodies moving around it in complex paths, using circles within circles, known as epicycles, to explain the irregular movements of planets like Mars and Jupiter. Copernicus noticed discrepancies in Ptolemy's model, which required increasingly complicated explanations to match observed planetary movements. He began to consider a simpler, more elegant solution: that the Sun, not the Earth, was at the center of the universe, and that the Earth and other planets orbited around it. This radical idea had been proposed in antiquity by philosophers like Aristarchus of Samos, but it was largely dismissed and forgotten. While living in Frombork, Poland, Copernicus continued his astronomical observations and calculations. With only the naked eye and basic measuring tools, he noted that the heliocentric, sun-centered model could explain the apparent retrograde motion of the planets. Retrograde motion, where planets like Mars seem to move backward in the sky, was easily explained by a heliocentric model, where Earth's movement caused the illusion rather than requiring complex circular motions. After more than 3 decades of study, Copernicus completed his magnum opus, De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres, around 1530. In it, he laid out the foundations of his heliocentric model in 6 books, carefully describing how the Earth rotates daily on its axis and how it, along with the other planets, revolves around the Sun. This model reduced the need for the complicated epicycles in the Ptolemaic system and offered a more straightforward explanation of planetary motion. However, Copernicus hesitated to publish his work. Aware of the potential backlash from the church and scientific community, who might see his ideas as heretical, he delayed making his findings public. It wasn't until 1543, the year of his death, that De Revolutionibus was finally published, largely due to the encouragement of his student, Rheticus, who believed that Copernicus's work was too important to remain unpublished. The initial response to Copernicus's theory was cautious but not overwhelmingly hostile. The Church initially tolerated his ideas, viewing them as a theoretical model rather than a factual account of the universe. However, over the years, as Copernican theory gained traction and was further developed by astronomers like Galileo and Kepler, opposition grew. By the early 17th century, the Church had banned De Revolutionibus, and the heliocentric model was officially condemned as heretical. The resistance Copernicus faced was partly due to the theological implications of a sun-centered universe. If the Earth was not the center of the universe, humanity's perceived place in creation was called into question. The heliocentric theory also challenged centuries of philosophical and religious teachings that emphasized Earth's central role in the cosmos. Copernicus's ideas did not die with him. Instead, they laid the groundwork for a scientific revolution. In the decades following his death, astronomers like Johannes Kepler and Galileo Galilei made further advancements. Kepler built on Copernicus's model, by discovering that planets move in elliptical orbits, not perfect circles, which helped refine the heliocentric theory. Galileo's use of the telescope provided observational evidence that supported Copernicus's model, such as the phases of Venus and the moons of Jupiter orbiting their planet, phenomena inconsistent with an Earth-centered universe. By the end of the 17th century, Isaac Newton's laws of motion and universal gravitation offered the theoretical framework that fully vindicated the Copernican model, making the heliocentric theory the foundation of modern astronomy. This shift from an Earth-centered to a Sun-centered universe fundamentally altered humanity's understanding of its place in the cosmos and ushered in a new age of scientific inquiry and discovery. Nicolaus Copernicus's life and work exemplify the courage to question established beliefs in the pursuit of truth. By placing the sun at the center of the universe, he ignited a scientific revolution that redefined humanity's understanding of the cosmos and laid the foundation for modern astronomy. Copernicus's legacy lives on, not only in the field of astronomy, but also in the enduring spirit of curiosity and intellectual bravery that drives scientific progress.